when you switch to Linux containers, you might have problems like how to run containers in productions or some problems regarding the development side, right? So for that, you need something more than well-prepared Docker files to move to the production, and that is the container orchestration system. So hello everyone, this is Sahiti on behalf of Edureka, and I welcome you to this session on Kubernetes tutorial. So thank you all the attendees for joining in today's session. Before we get started, all of you just give me a quick confirmation on the chat window whether I'm audible or not. Okay, I've got many yeses. Alright, so that's great. So now without wasting any further time, let's look into the topics for today's session. So we'll start today's session by understanding the challenges without container orchestration. Then I'll tell you why did we actually need container orchestration. After that, I'll tell you the differences between Docker Swarm and Kubernetes and then introduce to what is Kubernetes. Once you understand what is Kubernetes, I'll tell you the features of Kubernetes and then I'll mainly focus on the architecture of Kubernetes, in which we'll talk about various components of its architecture like the master node, worker node, and many others. And then finally, I'll end this session with a hands-on part where I'll be deploying the WordPress and MySQL applications with persistent volumes using Minikube on Ubuntu. Alright, so is the agenda clear to everyone? Okay, so that's great. So now let's get started with the first topic for today's session. Now, before we deep dive into, container orchestration, as I was telling you, we'll first talk about the system challenges without container orchestration so that you understand the need of container orchestration. Now, just assume any applications, right? It has multiple services running inside containers. Now, each containers have to be scaled, each containers have to be met with the complexities, the code has to be managed, and there are so many things. But before that, let me tell you that all the containers are good. Any container for the matter of fact, like a Linux container or a Docker container or even a Rocket container, they all do one thing. And what is it? They package your application and isolate it from everything else. So basically, they isolate the applications from the host mainly, and this makes the container fast, reliable, efficient, lightweight, and scalable. Now, as I was telling, the containers are scalable, but there are a few problems to deal with that. So just take a look at a container. Now you might want to probably scale it up to 2 containers or 3 containers. Well, you just want to scale it up to a definite number, right? But this is going to take a lot of manual effort. In real world scenarios, where you might want to scale it up like around 50 to 100 containers, then in that case, what happens is that after you scale up these containers manually, then you have to manage those containers. And by managing, I mean that you have to check whether all of them are working or not, they're active or not, they're talking to each other, because if they're not talking to each other, then there's no point of scaling up the containers, right? So it's a really big task to, handle so many containers manually. So containerization was basically a concept which was sold on the basis of scaling up. So as it is a known fact that the virtual machines cannot be scaled up easily, and containerization was a concept that was sold on the basis of scaling up. But in today's world, the demand is even more than the regular containers. That's because they're not enough. So to scale up these containers, we need something else to manage the containers so that you don't have to worry about keeping a track of them or to check whether they're active or not or to perform any such actions. So without container orchestration, it increases the human cost of running services. It also increases the size of bills from the public cloud providers, and that is about the cost efficiency I'm talking. It also increases the complexity of running something new in the production as everything else has to be scaled up again manually. So as setting up services manually was, really tough, scaling was also difficult and also the manual work increased. So to tackle all these problems, orchestration came into place. And when orchestration comes into place, that's where Kubernetes comes into the picture. So it's obvious that anybody would want a system which could manage your containers, launch them on the underlying machines, make sure that they're distributed and also keeps them healthy. And all this is achieved by none other than the orchestration engine. So Kubernetes or Docker Swarm are the top orchestration engines in today's market. So before you start using them in your productions, you should exactly know what they are and how they work, right? So to understand the same, let's talk about the performance and usabilities of Kubernetes and Docker Swarm. Now, before I tell you the differences between Docker Swarm and Kubernetes, Elisha just asked me a question that how is Docker Swarm different from Docker? So, well, Elisha, let me tell you that Docker Swarm is a container orchestration platform just as the same of Kubernetes, But Docker is a containerization platform. So Docker is where you deploy your containers, you can use your containers and you can make it Docker files, you can use Docker images and all. And Docker Swarm comes into place where you orchestrate those containers, right? So that's the basic difference between Docker Swarm and Docker. And that is the reason that we do not compare Docker with Kubernetes as the two different concepts completely. But whereas Docker Swarm and Kubernetes are orchestration platforms, so that is the reason that people compare these two terms. So is the difference clear to you? Okay, so that's great. So now let me tell you the differences between Docker Swarm and Kubernetes. Now, when you talk about auto scaling, Kubernetes wins the game clearly. That's because Kubernetes are intelligent enough to analyze your server load, and based on that, they can scale up or scale down based on the requirements. So there's no need for manual intervention because the traffic catastrophe can be now completely avoided. But when it comes to the case of Docker Swarm is not confident defender here. That's because when the traffic pours in, it crumbles with no help available, and because of which the manual intervention is definite over there. So in simple terms, if you want your application to be auto scaled, then Kubernetes is a better platform. Now when it comes to the load balancing, Kubernetes is beaten here. That's because at times you need to manually configure your load balancing settings. In Kubernetes, now multiple containers can be served as one pod and each service can be defined as a group of pods. But load balancing is very simple with the Swarm. That's because Swarm does auto load balancing. Now there is no concept of pods, and hence all the containers discover each other with the network IP address, which happens automatically as long as the nodes are connected to the cluster. So you just have to make sure that the nodes are connected to the cluster, and Docker Swarm makes it easy for load balancing. Now coming to the rolling updates and rollbacks, Kubernetes wins the game here again. In fact, both Kubernetes and Swarm clusters support the concept of rolling updates to the containers. Kubernetes perform rolling updates to pods as a whole, while Swarm does it to the containers straightway. Rolling updates is the process of progressively and gradually deploying the updates to the existing applications in all the containers. But Swarm is beaten here because it does not automatically roll back. So whenever something goes wrong while deploying your updates, both the Kubernetes and Swarm provide an option to roll back to the previous stable deployment. But only one thing over here is that the Kubernetes does auto rollback in the case of failure conditions, which Swarm doesn't. The master of the cluster closely monitors the updates and deployments and makes sure that the option of rollback is enabled. Right? Now coming to the next difference, that is data volumes. Kubernetes allows us to share storage volumes between the multiple containers inside the same pod. However, Docker Swarm allows to use the share storage volumes with any other container. But the advantage of Kubernetes is that the storage can be easily mounted on a local storage or either on a public clouds like AWS, GCP, or even on the shared networks like NFS. Not only these, but Kubernetes also provide inbuilt tools for logging and monitoring. So logging helps in quickly analyzing the logs and understanding where the problem lies in case of a failure. Monitoring helps the master to constantly be aware of the health status of nodes and the services containerized by them. So Kubernetes does inbuilt logging and monitoring, and Swarm uses the third-party tools like ELK stacks. So guys, these were some differences between Docker Swarm and Kubernetes. Sometimes Kubernetes wins and sometimes Docker wins, but maximum times Kubernetes wins, right? So now, as I was talking so much about Kubernetes, you might have a question. What exactly is Kubernetes and why do we need Kubernetes, right? So let's start finding out why do we need Kubernetes. So if you had an option of choosing between Docker Swarm and Kubernetes, which one would you choose? You would always go for Kubernetes, right? That's because Kubernetes offers auto scaling of containers based on the traffic needs. Not only this, but Kubernetes also offers the option of rolling updates, sharing storage volumes, and also providing the inbuilt tools for logging and monitoring. So all your tasks can be performed with ease and in a simple manner. So now that you've understood why do we need Kubernetes, you might have a question, what exactly is Kubernetes that I'm talking about, right? So as I mentioned before, Kubernetes is an open source container orchestration platform for automating deployment, scaling, and management of containerized applications. It basically groups the containers that make up an application into simple logical units for management and discovery. It is designed on the same principles that allow Google to run billions of containers a week, and Kubernetes can scale without your operations team. So whether testing locally or running on a global enterprise, Kubernetes flexibility grows with you to deliver your applications consistently and easily, no matter how complex your application is or how complex your need is. So you can just say that, Kubernetes is an open source which gives you the freedom to take full advantage of on-premises, hybrid or public cloud infrastructures and lets you effortlessly move workloads to where it matters to you, right? So guys, that was all about Kubernetes. It's just the open platform that is there for container orchestration and gives you all the advantages to be used, right? Now, as I was talking about Kubernetes, let me tell you various features of Kubernetes. So Kubernetes automatically places the containers based on the resource requirements and other constraints while not sacrificing the availability. So it mixes the critical and best effort workloads in order to drive up utilization and save even more resources. So you can say that it uses automated scheduling of resources to perform resource optimization. Now, there is no need to modify your application to use an unfamiliar service discovery mechanism. That's because Kubernetes gives containers their own IP addresses and a single DNS name for a set of containers which can load balance across them. Not only this, but Kubernetes also automatically mounts the storage system of your choice, whether local storage or a public cloud provider such as GCP, AWS, or a network storage system like NFS, ISCSI, Gluster, Ceph, Cinder, or Flocker. So it also restarts that fails, replaces and reschedules the containers when nodes die. It also kills the containers that do not respond to your user-defined health checks and doesn't advertise them to the clients until they're ready to serve. It deploys and updates the secrets and application configurations without rebuilding your images and without exposing the secrets in your stack configuration. In addition to the services, Kubernetes can also manage your batch and CI workloads by replacing containers that fail if desired, right? So it scales up your application up and down with a simple command with a UI or automatically based on CPU usage. Kubernetes also progressively rolls out changes to your application or its configurations while monitoring the application health to ensure that it doesn't kill all your instances at the same time. So in short, Kubernetes offers automated scheduling by which it provides the advanced scheduler options to launch the containers on cluster nodes as per the requirements. It has self-healing capabilities. So by that, I mean that it can reschedule, replace, and restart the containers which are dead. Not only this, but it also provides automated rollouts and rollbacks, by which I mean that Kubernetes supports the rollouts and rollbacks for the desired state of containerized applications, and it also provides the horizontal scaling and load balances so that you can scale up and scale down based on your requirements of the application, right? So guys, these were the features of Kubernetes. Now moving on with the session, let me tell you what are the components of Kubernetes architecture. So guys, as you can see on the screen, these are the different components of Kubernetes architecture. Now kubectl is basically the command line proxy through which you can access all your cluster services and the worker nodes, from which we have the master node, and the master node has an API server, controller manager, scheduler, which also have the etcd connected. Now to a single master node, we have various worker nodes having a kubelet process running with kubeproxy and n number of pods. Now, pod is the basic unit of a Kubernetes architecture, but let me tell you one thing, that a pod can have n number of container images. So this is how the Kubernetes architecture looks like. Don't worry, I'll be discussing about each one of these components. But yes, if you want a detailed explanation about all these components, then you can refer to the video of Kubernetes architecture that I'll mention in the description box. Alright, so let's start with the first component of Kubernetes architecture, that is master node. So the master node is the entry point for all the administrative tasks which are responsible for managing the Kubernetes cluster. There can be more than one master node in the cluster to check for the fault tolerance. More than one master node puts the system in a high availability mode in which one of them will be the main node which will perform all the tasks and the other will act as worker nodes. So for managing the cluster state, it uses the etcd in which all the master nodes are connected to it, right? Now moving on, as I was telling you, the master node has the API servers, controller managers, schedulers. Let me tell you what exactly the API servers and etcd do. Well, the API server is the entry point for all the REST commands used to control the cluster. So basically, you can say that all the administrative tasks are performed via the API server within the master node. So a user sends the REST commands to the API server, which then validates and processes the request. So after executing the request, the resulting state of the cluster is stored in the distributed key value store. Now coming to the working of etcd. So etcd is a distributed key value store which stores the cluster state. So it can be part of the Kubernetes master or it can be configured externally. etcd is basically written in the Go programming language, and in Kubernetes, besides storing the cluster state, it is also used to store the configuration details such as the subnets, config maps, secrets, and many more. Now, moving on to the scheduler and the controller manager components of the master node, let me tell you that the scheduler schedules the tasks to the slave nodes. So it stores the resources usage information for each slave node, and then it schedules the work in form of pods and services. So before scheduling the task, the scheduler also takes into account the quality of service requirements, data locality, affinity, and anti-affinity. Coming to the controller managers are also known as the controllers. So it is a daemon which regulates the Kubernetes cluster, which manages the different non-terminating control loops. So it also performs lifecycle functions such as namespace creation and lifecycle, event garbage collections, terminated pod garbage collection, cascading deleted garbage collections, node garbage collections, and many more. So basically, a controller watches the desired state of objects as it manages and watches their current state through the API server. If the current state of the object it manages does not meet the desired state, then the control loop takes the corrective steps to make sure that the current state is same as that of the desired state. So guys, that was all about the components of Kubernetes master node. Now as you saw that the Kubernetes architecture also has the worker node. So now let's discuss the components of the worker node. So before I tell you the components of the worker node, let me tell you what exactly is the worker node. So worker node is basically a physical server, or you can say a virtual machine, which runs the applications using pod, which are then controlled by the master node. So on a physical server, which is basically the worker or the slave node, pods are scheduled, and then for accessing these applications from the external world, we connect to the nodes. So now let's see what are the components of the worker node. So as you can see, there are mainly two components of the worker node, that is the kubelet processes and the kube proxy. Now kubelet is an agent which communicates with the master node and executes on the nodes or the worker nodes. It gets the pod specifications to the API server and executes the containers associated with the pod and ensures that the container described in the pods are running and healthy. Now, when it comes to the kube proxy runs on each node to deal with the individual host subnettings and ensures that the services are available to the external parties. So it serves as a network proxy and a load balancer for a service on a single worker node and manages the network routing for TCP and UDP packets. It is the network proxy which runs on each worker node and listens to the API server for each service endpoint creation or deletion. So for each service endpoint, kubeproxy sets up the route so that you can reach to it. So guys, that was about the components of the worker nodes. So now that you've understood why do we need container orchestration, what exactly Kubernetes is, what is the architecture of Kubernetes, now let's move on to the practical part of the session where I'm going to deploy the WordPress and the MySQL applications with persistent volumes by using Minikube on Ubuntu, right? So guys, let's get started with the hands-on part. So we're going to deploy a MySQL and a WordPress applications with persistent volumes. So what do you think these persistent volumes are? Where persistent volume is a space of storage in the cluster that has been manually provisioned by an administrator or dynamically provisioned by Kubernetes. So a persistent volume chain is a request for storage by a user that can be fulfilled by the persistent volume. Now, let me tell you that the persistent volumes and persistent volume chains are independent from the pod life cycles and preserve data through restarting, rescheduling, and even deleting the pods, right? So now let me tell you the steps that we're going to do to deploy these applications. So we're going to first create the persistent volume chains and persistent volumes. Then we're going to create secrets. Then we're going to deploy the MySQL application. And similarly, we're going to deploy the WordPress application. And then finally, we'll perform the cleanup action. So I'm assuming that all of you have Kubernetes installed on your system. So now before you begin with the steps of the hands-on part, you have to first initialize the Kubernetes cluster on your master machine node. So for that, you have to get the super user access by the command sudo su, and then you have to type in this command. So this will basically initialize your cluster on the mentioned IP address. So you just mention your IP address and then it will initialize the cluster. Now, as you can see that we have got an error, that's because we already have the Kubernetes clusters initialized on my system. So to reset this, you have to type in the command kube adm reset and then press on Y. Now, once you're done with this, again mention the command to initialize the cluster. So this will basically initialize your Kubernetes cluster on the master's machine. Now you can see that our cluster has been initialized. So now to deploy the applications, I'll be using the Minikube. So let me deploy Minikube first. So to deploy Minikube, you'll type in the command Minikube start. So now as you can see that our Minikube is starting, let me discuss the first step, that was creating persistent volume chains and persistent volumes. So the MySQL and the WordPress applications each require a persistent volume to store the data. So their persistent volume chains will be created at the deployment step. But before that, let's start by creating the secret for MySQL password. So now you can see that your Minikube has started. So now let's start by creating a secret for the MySQL password. So a secret is basically an object that stores a piece of sensitive data like password of the key. So before I start creating the secret object, I'll be clearing my screen. So for that, you have to type in the command clear and this will clear your screen. Now let's start by creating the secret object for the MySQL. So to create a secret object, you have to type in the command kubectl create secret generic mysql -pass space -- from -literal is equal to password and then mention your password. Over here, I've mentioned Edureka 123. After you're done with that, click on enter. So you can see that the secret MySQL pass has been created. Now once that is done, to verify whether that secret exists or not, you have to type in the command kubectl get secrets. So you can see that MySQL pass secret is present. Now once your secret has been created, you have to deploy your MySQL container. So to deploy your MySQL container, you would need a YAML file, and I've already created my YAML file. So I'm going to use the same YAML file to deploy the MySQL container. So to deploy this container, you'll use the command kubectl create -f and then you'll mention the directory where that file is present. So now that I've deployed my MySQL deployment file, let me show you what are the configurations that I've mentioned inside my YAML file. So for that, let me open my YAML file. So as you can see, I've mentioned API version to be V1, the kind to be service, because this is not a deployment, this is a service that we're trying to create. The name of the file to be WordPress MySQL. The labels that I'm going to mention is WordPress. It's going to run on the port 3306. The tier to be MySQL, and I've assigned no cluster IP at present. So similar to which, in case, since we are creating the persistent volume chains, I've mentioned its configurations also. Its API version is same as that of the service, that is V1. The name to be MySQL-PV-claim. Labels is same as that of the service, that is WordPress. Its specifications include read-write once, and then we have provided 20 gigabytes of storage, right? So guys, that was about the YAML file. Now let's go back to the steps, and now let's verify if the persistent volume got dynamically provisioned or not. So for that, you have to use in the command kubectl get pvc. Okay, so you can see the output that it has been dynamically provisioned. Now what you have to do is you have to verify if the pod is running or not. So for that, you have to type in the command kubectl get pods. So now you can see that there's a single pod in the running status. So that was all about deploying MySQL. So now our next step is to deploy the WordPress. So we're going to follow the same steps that we followed for deploying MySQL. So first you have to again create a WordPress service and deployment. So for that, you'll type in the command kubectl -f and mention the directory where it is present. So since I've already created my YAML file, I've just mentioned the directory, and yes, our services and deployment file has been created. Now before I move on, let me open the YAML file and let me show you the configurations I've mentioned over there. So guys, this is my YAML file. So for the services, I've mentioned API version to be V1, the kind to be services because I want a type of service to be done. So the type of service I'm going to use is the load balancer, whereas the type of service that I used for MySQL was the default, that was cluster IP. The name to be WordPress, the labels again named to be WordPress. It's going to run on the port 80 and tied to be front end because it is a front end application that we're dealing with. Not only this, when we are creating the persistent volume chain, I've also mentioned those configurations. So the API version stands the same, that is V1. The kind to be persistent volume claim. the name to be wp-pv-claim, labels app again to be WordPress. Now specifications include the access mode to be read write once, and the storage is again allotted. And similarly for the deployments, I've mentioned the configurations. So guys, that was my YAML file. Now let's go back to the steps and let's verify if the persistent volume got dynamically provisioned or not. So for that, you have to type in the command kubectl get pvc. So you can see that a WPV claim has been successfully provisioned. Now you have to check whether the service is running or not. So for that, you have to type in the command kubectl get services WordPress. So you can see that our service WordPress is definitely fine with the type to be load balancer and is allotted with a cluster IP, right? Now you can see on the screen that the external IP is still pending. That's because Minikube can only expose services through the node port, and external IP is always pending because it's not node port that we are using. So now after this step, what you have to do is you have to get the IP address for the WordPress service. So for that, type in the command minikube service WordPress space hyphen hyphen URL. So the response will give you an IP address for the WordPress service. So let me copy the IP address. Let's go to the web browser and view the site. So let me paste it over here. So as you can see on the screen, the WordPress has been deployed. Now if you click on the continue button, you can see the welcome page of WordPress where you can provide the information needed such as the site title. So let's say I type in Edureka demo. Let's say I type in the username to be Edureka123, password to be as it is, and let's say I mention an email ID. Let's say sahiti@edureka.co. Now once that is done, you can click on install WordPress and this will install your WordPress, right? So guys, that was how our WordPress application got deployed. So now as you can see that our WordPress has been installed with the username and the password mentioned. So guys, that's how you can deploy the MySQL and WordPress. Now if you want to delete your secret, you have to type in the command kubectl delete secret mysql-pass. So that's the name of the secret that we created, right? So that is mysql-pass over here. Now once you enter this command, you can see that your secret has been deleted. Now if you want to delete all the deployments and services also, you have to type in the command kubectl delete deployment space -l space app equal to WordPress. So that is the name of the deployment that I've given. So you can give the name of the deployment that you have given. So once you enter this command, you can see that your deployment has been deleted. In the similar way, you can delete your services by typing the command kubectl delete service -l app equal to WordPress. That is the name of the service that I've given. So when you type in this command, you can see that your service has also been deleted. Now if you want to delete your persistent volume claim, you just again have to type in the command kubectl delete pvc-l app equal to WordPress, right? So guys, that's how you can delete your secrets, deployments, services, and persistent volume claims. So guys, that was a short demo on Kubernetes, and that's all for today's session. I hope you found this session informative. Thank you and have a great day.
I hope you have enjoyed listening to this video. Please be kind enough to like it, and you can comment any of your doubts and queries, and we will reply them at the earliest. Do look out for more videos in our playlist and subscribe to Edureka channel to learn more. Happy learning!